All right, let's go.
Number 7. The sun has produced storms far worse than the Carrington event, and we only found out from trees. Most people know about the Carrington event of 1859 as the worst solar storm in recorded history, the benchmark, the worst case, the thing scientists compare everything else to. It is not the worst case. In 2012, a team of Japanese researchers published something in the journal Nature that quietly rewrote the upper limit of what the sun is capable of. They were analyzing carbon-14 levels in ancient tree rings, specifically Japanese cedar trees, when they found a sudden, massive spike in the years 774 to 775 AD. Not a gradual change, a sharp vertical jump in radioactive carbon-14 that was 20 times larger than anything seen in the modern record. Carbon-14 is produced in the upper atmosphere when cosmic rays, including high-energy particles from the sun, strike nitrogen atoms. A sudden spike in carbon-14 means a sudden, massive injection of energetic particles from space. The 774 to 775 AD event, now called a Miyake event after its discoverer Fusa Miyake, was subsequently confirmed in tree ring records from around the world, in ice cores, in coral. It happened globally. It was real. The energy involved was far beyond the Carrington event. Researchers estimated the solar proton fluence from this event was between 10 and 100 times larger than the highest recorded modern events. If this event happened today, the radiation dose to astronauts in low Earth orbit would be lethal without adequate shielding. Satellites would be destroyed. The ionosphere would be so severely disrupted that radio communication could be lost globally for days. A second Miyake event was identified in 992 to 993 AD. In May 2026, scientists announced the discovery of a third, from approximately 1200 to 1201 AD, identified in ancient Asunara wood from Aomori Prefecture in Japan, cross-referenced against Chinese historical records describing a red aurora visible at unusually low latitudes during that same period. 3 Miyake events in the last 1,500 years, roughly one every 500 years. The last one was 800 years ago. We are not outside the statistical window for the next one. In the Carrington event, the storm our entire planetary defense planning is built around was not even close to what these events produced. The sun does not reach its maximum on solar maximum. It reaches its maximum in moments we have only just discovered existed. Number 6. Solar flares may be triggering earthquakes, and a new study in 2026 says how. This one was published in February 2026, and it is deeply uncomfortable. A research team published a new proposed mechanism in the International Journal of Plasma Environmental Science and Technology. The paper, led by Mizuno, Kao, and Umeno, proposed a specific physical pathway by which solar flares could trigger earthquakes, not through ground shaking, not through atmospheric pressure, through electrostatics. The mechanism works like this. When a solar flare fires, the electromagnetic radiation arrives at Earth in 8 minutes and begins ionizing the upper atmosphere, the ionosphere, immediately. The ionization shifts the distribution of electrons in the ionosphere, concentrating them at lower altitudes and creating a layer of excess negative charge. That charge increases the electrostatic force acting downward on the Earth's crust. The researchers calculated that under the right conditions, specifically near fault zones already under significant tectonic stress, this added electrostatic pressure could be enough to nudge a fault from stable to unstable. The 2024 Noto Peninsula earthquake in Japan overlapped with strong solar flare activity in the days preceding it. Japan's seismic network recorded anomalous ionospheric total electron content spikes in the hours before the quake. The timing aligned with the model's predictions. This is not confirmed, it is not consensus. Opponents note that the electrostatic forces involved are orders of magnitude smaller than the tectonic forces that drive earthquakes. Correlation between solar events and earthquake clusters has been identified in the historical record, but proving causation has remained impossible. But the study is real. It is peer-reviewed. It was published in 2026 at solar maximum, a period when solar flare frequency is elevated dramatically. And if the mechanism is even partially valid, it means a major X-class flare could be a seismic trigger in fault zones already near the breaking point, not something we have ever included in earthquake risk models. The sun has never been considered a geological hazard before. As of 2026, it is being modeled as one. Number 5. The sun is evaporating the atmospheres of other planets and other star systems, and it once did it to one of ours. JWST has been observing exoplanets with a level of atmospheric detail that was not possible before 2022. Its recurring findings are a category of planets that should not exist, planets in the mass range between Earth and Neptune that are missing their expected atmospheres entirely. This gap in the planet size distribution, called the Radius Valley or the Fulton Gap, was identified statistically in Kepler data in 2017. Planets tend to cluster below 1.5 Earth radii and above 2 Earth radii. There is a suspicious absence of planets in between. The leading explanation is photoevaporation, stellar radiation stripping away the atmospheres of planets that started out as mini Neptunes, leaving behind bare rocky cores. The stripped planets become the sub-Earth or super-Earth rocky worlds. The ones that kept their gas became mini Neptunes and beyond. This process is ongoing. JWST has directly observed atmospheric evaporation in real time around exoplanets orbiting close to their host stars. Ultraviolet radiation from the star heats the upper atmosphere past escape velocity. The gas bleeds off continuously. Planets lose their atmospheres over millions to hundreds of millions of years. The sun did this to one of its own planets. Venus may have had a surface ocean and a habitable climate during the first billion years of the solar system's history, before the sun gradually brightened, as all main sequence stars do over geological time, and tipped Venus past the runaway greenhouse threshold. The water evaporated. The water vapor was broken apart by ultraviolet radiation from the sun. The hydrogen escaped to space. The oxygen reacted with the surface rock. What is left is 465-degree acid rain and 92 atmospheres of pressure. Earth will face the same thing. As the sun continues brightening over the next billion years, its luminosity will eventually push Earth past the inner edge of the habitable zone. Not dramatically, not suddenly, slowly and permanently. The oceans will begin to evaporate. The water vapor will amplify the greenhouse effect. More water evaporates. Positive feedback. The oceans will be completely gone in approximately 1 to 1.5 billion years. Photosynthesis will be impossible within a few hundred million years before that. The sun, the same sun that made every form of life on this planet possible, is the mechanism by which it all ends. It is not doing this out of hostility. It's just a star following the laws of physics. We are somewhere in the middle of the window. Number 4. The Inouye Solar Telescope just showed us what the sun actually looks like, and it is not what anyone expected. In June 2025, the NSF's Daniel K. Inouye Solar Telescope, the most powerful ground-based solar telescope ever built, published images of the solar surface at a resolution that had never been achieved before. Images capable of resolving structures just 20 kilometers across on an object 150 million kilometers away. What those images showed were magnetic structures on the solar surface so fine-grained, so small and so numerous that they fundamentally changed how physicists think about where solar flares are energized. Tiny hair-like magnetic strands called fibrils covered the surface in dense interlocking sheets, magnetic field lines threading the photosphere and structures far more complex and far more tangled than existing models described. And embedded in these structures, the source of the instabilities that eventually cascade into solar flares, a process that researchers described as magnetic avalanches. Solar flares do not simply fire from large sunspots like a battery discharging. The energy builds through the continuous complex tangling of thousands of small-scale magnetic structures across a region of the solar surface. When enough of these small-scale structures align and reconnect, the energy cascades upward through scales, small reconnections feeding energy into larger ones until a macroscopic explosion erupts. This finding matters for one specific and alarming reason. Solar flares are powered by cascading processes across enormous numbers of tiny magnetic structures rather than a small number of large sunspot groups. Then large flares can potentially emerge from sunspot regions that appear relatively modest from Earth. A region that looks small and manageable in routine solar monitoring could contain the microscopic complexity needed to cascade into an X-class flare. Our forecasting models were built for the smooth surface picture. The Inouye telescope has shown us the actual surface. The two do not look the same. Number 3. The sun's energetic particles reached the deep ocean, and we have never thought of that before. This one was identified in the months following the May 2024 Gannon storm, when scientists began combing through every data source they had for effects of the storm. They found something nobody expected. Deep-sea pressure sensors and ocean monitoring buoys recorded anomalous signatures during the peak of the Gannon storm in May 2024. Researchers published a study confirming that the geomagnetic storm's effects were measurable in the deep ocean. The storm altered electrical currents in the water column. Magnetoreception in marine creatures, the ability of sharks, rays, sea turtles, and migrating whales to navigate using Earth's magnetic field, was temporarily disrupted during the storm's peak. For animals that navigate using magnetic field lines, the Gannon storm was the equivalent of someone quietly rearranging every compass on Earth at once. During the 2003 Halloween storms, researchers had already documented mass strandings of sperm whales in the North Sea in the weeks following the event. A 2020 study had quantified a significant correlation between solar radio flux, the level of radio emission from the sun, and humpback whale strandings. The proposed mechanism is that the disruption to Earth's magnetic field during intense solar events causes navigational errors in whales using magnetoreception. Not immediately, over days, as the animals gradually drift off course. The deep ocean connection confirmed in 2025 adds a new dimension. The sun does not just disrupt satellites and power grids during major storms, it reaches into the deep ocean and briefly scrambles the navigational senses of creatures that have been using magnetic field navigation for tens of millions of years. A star 150 million kilometers away can disorient a whale in the Pacific Ocean. This was not in any model before 2024. Number 2. The sun can produce a super flare. Our models said it could not. They were wrong. Super flares are flares at least 10 to 100 times more energetic than the most powerful solar flare ever recorded, the kind of events that occur routinely on magnetically active young stars, but were considered impossible for a quiet, middle-aged star like our sun. Then Kepler started watching 83,000 sun-like stars simultaneously. Over 4 years of continuous photometric monitoring, Kepler detected 365 superflares on 148 sun-like stars, stars with the same spectral type and approximate age as our sun. Quiet, stable, ordinary stars producing flares so powerful that a comparable event on our sun would make the Carrington event look insignificant. The follow-up analysis published in subsequent years showed the rate of superflares on sun-like stars puts the statistical likelihood of our own sun producing one at roughly once every few thousand years, not once per million years, once per few thousand. And researchers at Kyoto University published data in 2022 and updated in 2025, suggesting that giant sunspot groups, far larger than anything in the modern record, but consistent with the historical sunspot record, are a necessary condition for superflares, and that our sun has produced sunspot groups of comparable size in the past. The Miyake events in the tree ring record may themselves be the signature of superflare class events. The 774 to 775 AD spike was large enough to be consistent with a superflare or an extreme solar proton event associated with one. A solar superflare would make GPS, radio communication, and power grid vulnerability look like minor inconveniences. The radiation pulse from a superflare carries enough energy to strip significant portions of the ozone layer. Enhanced UV reaching the surface following ozone depletion causes crop failures on a scale that makes agricultural GPS losses from the Gannon storm irrelevant. Researchers have modeled the atmospheric consequences of a solar superflare and found potential ozone reduction of up to 40% at mid-latitudes for years following the event. For decades, the consensus was that our sun was too old and too stable for superflares. The consensus is no longer that comfortable. Number 1. The sun is going to kill everything on a schedule. Everything in Part 1 described what the sun is capable of now. Storms, flares, stripping atmospheres, triggering earthquakes, disrupting satellites. This one is not a storm risk. It is not a solar maximum concern. It is what happens when the sun just keeps being the sun. The sun is currently about 4.6 billion years old. It is a G-type main sequence star. It has roughly 5 billion years of hydrogen burning left before it exhausts its core hydrogen and begins transitioning off the main sequence. It is also getting brighter. Every billion years, the sun's luminosity increases by approximately 10% as the helium builds up in its core and the fusion rate adjusts. Over the next 600 million years, this brightening will push the inner edge of the habitable zone past Earth's orbital distance. Surface temperatures will rise beyond what the carbon silicate cycle can compensate for. The runaway greenhouse effect will begin. Within a few hundred million years after that, the oceans will be completely evaporated. Then the sun will expand into a red giant. It will swallow Mercury, swallow Venus. Whether it swallows Earth is still debated. Some models say yes. Some say Earth's orbit expands slightly as the sun loses mass and escapes just outside the outer envelope. Either way, Earth's surface will be sterilized by the heat of a star that has expanded to over 100 times its current radius. There is no geological process, no human response, no technological solution that changes this timeline. It is simply what main sequence stars do. They brighten, they exhaust their fuel, they expand, the planets nearest them get consumed. What makes this entry the most disturbing isn't the scale of the event. It is the indifference. The sun does not do this to us, it just does it. The same nuclear physics that powers every form of life on this planet is, on the relevant timescale, also the mechanism by which all of it ends, slowly, steadily, without noticing. The sun has no record of what it is doing to us, no awareness that anything is here to be affected, no mechanism for stopping. It just keeps burning. 7 more things scientists have found about the sun that nobody talks about at the scale they should. Storms larger than the Carrington event, hidden in 800-year-old trees. Solar flares potentially triggering earthquakes through electrostatics, a 2026 paper that rewrites the risk profile. A sun that evaporates atmospheres and is slowly doing it to Earth on a billion-year clock. A solar surface far more complex and far more dangerous than our forecasting models assumed, revealed for the first time by the Inouye telescope in 2025. A storm that reached into the deep ocean and scrambled the navigation of whales. A star capable of superflares that would make the Carrington event look like a minor inconvenience. And the scheduled end. Not a risk, not a probability, but a certainty, written into the physics of what a star does when it ages. The sun gave you everything. It also has a timeline, and you are on it. Subscribe to Cosmichives. See you in the next one.